All right, so we have another conic section to talk about, and that's hyperbolas. So we're going to start off with the definition. A hyperbola is the collection of all points in a plane such that the difference of the distance between any point to each focus is constant. And so what they mean by difference is if you subtract them. So if you look at the back page of your resource packet on conics, you can see two different pictures of hyperbolas, two different orientations depending on the equation. So what the definition means is if I pick a point right here, and I find this distance right here, and I find this distance right here, and I subtract them, that number is exactly the same as if I take this point and find this distance right here and this distance and subtract them as well. And it's exactly the same number as if I take this point right here and find, oh, I was looking at the vertices, not the focus. Sorry, let me do that again. So if I took this point and took this distance and subtracted them, or took this point and took this distance and subtracted them, or if I took even like this point right here and took this distance and that distance and subtracted them. So that's all the definition is saying, is that if you took any point on the curve and looked at the distances from that point to each focus and subtracted those differences or those distances, because it says the difference, that amount will always be the same. It will be constant. Okay, so let's go ahead and label some more things in this. You can see lots of things labeled already that should be kind of similar. So if we look here, we have HK, that's the center. We know that from the center you go on amount A to the left and right, and you go on amount B up and down. And even though they have these kind of co-vertices labeled, we typically don't find them, to be honest. You really only find these vertices. And then you can see the focus is kind of inside the curve, which is typical, right? The curve like curls this way, so it's inside. But there's some extra things about hyperbolas that are a little bit different, which is why we're doing the unit and the order that we're doing it in. So we have asymptotes, and if you look, they cross straight through the center, and you can see this kind of rectangle here. And this is how you graph a hyperbola. You kind of draw this rectangle and draw the asymptotes, and then your curves can kind of follow that. So we'll look at that in a problem in the notes coming up here soon. But we are going to be able to find these asymptotes by hand based on having the equation. And then we also have axes of symmetry like we did before, but of course they have different names. So we're going to go ahead and label some extra stuff in our picture. So the axis of symmetry that goes like right through here, it goes through the focus and the vertex and the center and the other vertex and the other focus. This one right here is called the transverse axis. And then this axis of symmetry right here, so here you have like the hyperbolas folded in half over the transverse axis. This other axis, it's like one hyperbola folds on top of the other one. This axis of symmetry right here is called the conjugate axis. I don't know where those names came from, so if you're really curious, I will try to find it for you, but if you guys aren't curious, then I'm not going to spend the time. All right, so we have all that. The last thing that we want to go ahead and write on here is how to find the asymptotes. And so I'm going to go ahead and add this to our notes right down here. y minus k equals positive or negative, well, positive and negative, b divided by a times x minus h. So if you can see, the b over a forms the slope. You have the rise, or the up and down part, divided by the run, the left and right part. And then here's our x coordinate, and then here's our y. So y equals mx. The plus b part is going to kind of be formed by taking this and multiplying it by the h, and then taking this k value and moving it over. So the reason I wrote the asymptote like this is because y minus k comes directly from the equation. So what it means is you can take that set of parentheses and just stick it right here. You can take this set of parentheses and just stick it right here, and then you just have to square root these two numbers and divide them, right? So with the asymptotes, we always have two. We have plus or minus right here because, as you can see, one asymptote is going to have the positive slope, one asymptote is going to have the negative slope, all right? And so this is how we start writing the asymptotes, but we are always going to simplify to y equals mx plus b form. All right, we're always going to take this information and simplify it to y equals mx plus b. This is not, well, we could probably graph it from that, to be honest, but this is a skill that I would like for you to have, which is what I'm going to make you do. Okay, so we spent so much time looking at this hyperbola, we didn't really look at the other one yet. If you look at this equation, you can see that this is very similar to what we remember about an ellipse equation, except that it has a minus in the middle. So these are pretty easy to recognize. If you look at the other orientation where the curves go up and down instead of left and right, then you'll notice that the two terms have switched and the y squared term comes first. And so that's the part that we're going to notice when we do these problems is we're going to say, okay, if the y is first, then the curve is up and down. If the x is first, then the curve is left and right. It does not matter which number is bigger, A or B. The size of those numbers does not matter for hyperbolas, not one little bit. So here, again, we're going to go ahead and label those axes of symmetry. So we have the one that cuts the little U shapes in half, and that's the transverse axis. So this one right here, I'll go ahead and label it right there. That is the transverse axis. The one that cuts this way is the conjugate axis. And then again, we have the asymptotes. The asymptotes are found the exact same way, regardless of the orientation. So that formula that we already wrote is still going to work. And then down here, you'll notice that you're still going to find C to look for your focus, or foci, I guess, because there's two of them. And the difference here is that you have a squared plus b squared instead of a squared minus b squared. So if you had to memorize this, which you don't, but if you had to, you would say that since an ellipse has a plus in the equation, the formula for C has a minus. Since the hyperbola has a minus in the equation, the formula for C has a plus. So you'll just notice that those signs are opposite. Okay, so let's go ahead and do some work, I guess, to be able to find all these different things. I'm going to add one more thing to your notes, just because I think it makes sense, but just in case you kind of brain fart later on. For this one, we would say that the direction of this one is along the x-axis. And for this one, we would say the direction is along the y-axis. So I think we're good with that stuff. All right, now we're going to go ahead and do one of the problems where I give you an equation in standard form and we just do everything to it. And then after that, we'll look at some of the problems where there's a little bit more solving to do. So first example, we are going to graph x minus 2 squared over 16 minus y plus 3 squared over 4 equals 1. And so we're going to go ahead and find as many things as we can first so that it can make our graphing easier. So I'm going to say the center of this is positive 2, negative 3. And the direction of this, since the x squared term comes first, the direction is along the x-axis, and so that means we're going to be opening these curves left and right. I'm going to go ahead and do the work to write the equation of the asymptote. Well, technically you don't really have to know the equation of the asymptotes to graph this. Let's go ahead and just start graphing it now, actually. Okay, so here we have the center is 2, -3. We're going to have to go left 4 and up and down 2. So, well, left and right. So the way that we start graphing this is very similar to an ellipse, actually. So, right 2, down 3. So right 2 down, 1, 2, 3. There's the center. And then from there, we're going to go up 2 and down 2. We're going to go right 1, 2, 3, 4. We're going to go left 1, 2, 3, 4. Okay, now if this was an ellipse, you would just start drawing the ellipse, right? But it's not. So what we end up doing here is we actually draw a rectangle. And the thing is that the ellipse technically works with a rectangle too. It's like an ellipse is drawn inside the rectangle and a hyperbola is drawn outside the rectangle, if that kind of makes sense. So what we do next, it appears that I do not have a ruler inside my book. Dang it. Okay, so what we do next is we take a straight edge, and it's going to be a dirty sticky note, and we draw from one corner of the rectangle to the other. And you can see it goes right through the center. So here's one asymptote. I'm not graphing it from its equation, I'm just graphing it from this rectangle right here. And then I'll go ahead and draw the other asymptote, again, going through the center. And this, since you drew a sketch, unless you actually have graph paper, it's okay if your drawing isn't perfect. I was pretty careful when I drew my grid to make it as square as I could. Okay, so when we start drawing a hyperbola, regardless of the orientation, we always start off the same. So we always start off drawing that center, we always start off drawing that rectangle, and then from there we look at the equation and say, okay, should I use these two as the vertices, or should I use these two as the vertices? So since I have the x part in front, that means that I'm going to be drawing these ones as the vertices, and so I'm just going to follow that asymptote out here, and follow that asymptote out here, and then the same thing on the other side. I'm just going to follow that asymptote, follow the asymptote. If these had been switched, then we would have been doing up here and down here, but using the exact same rectangle, exact same asymptotes. Okay, so now we can go ahead and fill in some other information. So we have the vertices, which in this case were left and right, left 4 and right 4. So left 4 is -2, -3, right 4 is 6, -3. I'll go ahead and find the foci, which is always along this kind of axis with the vertices, just like we remember learning for our ellipses. And so I'm going to say c squared equals a squared plus b squared, which is 16 plus 4. So c squared is 20, which means that c is the square root of 20. So from the center, I'm going to go left square root 20 and right square root 20. So to left square root 20 and right square root 20. All right, the transverse axis goes right through here. It cuts those curves in half. And that's a horizontal line, so it's y equals, it goes right through the center, and so it's y equals -3. The conjugate axis is a vertical line that goes straight through the center, so that's x equals, and that'd be x equals 2. All right, and then let's go ahead and do the work to find the asymptotes. So I take the y parentheses, y plus 3 equals plus or minus b divided by a, so that would be 2 divided by 4. You'll notice that I'm square rooting those. 2 divided by 4, and then I take my x parentheses. Right? Now, once I have this written down, I do have a plus minus, so I'm going to go ahead and do this twice. Okay, once for the plus, once for the minus. So positive 1/2, negative 1/2. Okay, so 1/2, I'm going to go ahead and distribute that 1/2. 1/2 x minus 1, and then I can subtract the 3 over. Positive 1/2 x minus 4. And then negative 1/2, when I multiply it, is negative 1/2 x plus 1. And then I'll go ahead and minus the 3 over. So that's negative 1/2 x minus 2. And so if you look at these asymptotes we drew, you can see that here's an x-intercept of -2, and the slope goes down 1 over 2, down 1 over 2, so that's this asymptote. And then the other x-intercept is at -4, and this one goes up 1 over 2, up 1 over 2. And so that's the other asymptote. So we did find everything that we needed to find. Okay, next example. It says find the hyperbola with the center -3, -2, a focus at -3, -2 plus 2 square root 74, and a vertex at -3, -12. Okay. So just like I was saying with the other conic sections that we've studied, if you ever get stuck on these, often cases drawing a little sketch is going to help you figure some of the numbers out and have them make sense. So I'm going to go ahead and think about the center and the vertex, because I want to know if this equation should start with an x or if it should start with a y. So I'm going to go left 3 down 2, and then left 3 down 12. So here's the center, here's the vertex. That means that the curve is opening up and down. So since the curves are going to be up and down, that means that we're going to start with the y equation. So y squared minus x. So the center is at -3, -2, so that means this is going to be plus 2. This is going to be plus 3. All right. From the center, it went from -2 to -12, so that's a distance of 10. So the up and down amount is 10. That means that underneath the y term, we're going to have 10 squared, which is 100. All right. So this right here means that b equals 10. Just like before when we studied the ellipses, we know that the c value comes from the focus always. So here's the center, the -3, -2. That means that this right here is c. All right. So if we have c squared equals a squared plus b squared, we are solving for a squared. We know that b squared is 100. C squared is going to be 2 times 2 is 4, times the square root of 74 squared is just 74. And so that means that the C value is 4 times 74, that's 296. No, I did not do that in my head. So if we subtract 100 over, that means that 196 equals A squared. And then we have that. And we are done. All right, and then let's do one last example. We're going to find the hyperbola with the vertices -1, 5, and -1, -13, and asymptotes y equals 9/5, x minus 11/5, and y equals -9/5, x minus 29/5. Okay, so the asymptotes are something new. That's a different piece of information than we're used to having, but we do remember from the ellipses that when we have two vertices, it's very easy to find the center. And so when I look at this, I'm going to go ahead and find kind of like the middle of these 2 points. So I know that the center is going to have an x-coordinate of -1. I don't really have to do much with that. But to find the y-coordinate, I can just add the two y values together and divide them in half. So -13 plus 5 is -8. -8 divided by 2 is -4. So -1, -4 is going to be our center. Again, if I just kind of draw a little sketch of this to see what the orientation of this curve is, I've got left one up 5, left one down 13, and those are my vertices, and so that means that my curves are going up and down like this. So that means we're starting off with a y. So I can say y plus 4, x plus 1, making sure that I'm keeping the x-coordinate with the x and the y-coordinate with the y. From the center, from -4 up to +5, or from -4 down to -13, that's a distance of 9 each direction. And so that means that I have b equals 9 and b squared equals 81. Okay. Next, I can go ahead and look at my asymptotes. The asymptotes confirm the b value that you have, and they give you your a value, because if you remember, the slope is always b over a. Now you have to be careful because that b over a value can be simplified. All right, so what you always want to do is you want to take the 9 over 5 and set it equal to what you have. So I had that my b was 9, so I'm going to say 9 over a. All right, now if you had a different, let's say that my b value had been 18, then I would know that this fraction had been simplified from having an 18 on the top. Okay, so that's why I'm setting this up as a proportion. Even though I know if the b is 9, the a has to be 5. I'm just doing this in my notes so that if I have a situation where the b over a had been simplified, I'll know how to work with that situation. So now I'm going to go ahead and cross multiply. I have 45 equals 9a. I'm going to go ahead and divide by 9, and of course I get that a is 5, which is what I expected. So now I can go ahead and say 5 squared is 25. So just like when we learned before that anytime we saw a focus, we would translate in our head, that means that they gave us the C value. Whenever we see an asymptote, we need to translate in our head, that means they gave us the simplified form of B divided by A. So if we can find an A or a B somewhere else in the problem, then we can use this to find the other one.